All right, welcome to Algebra 2. Of course, I'm not here today, so this is our agenda for today. We're gonna have a warm-up. You're gonna take notes on 1.7, which is, I think, our last section in chapter 1. So you need to follow along here. If you want to pause the video, go back and forth, feel free to do that. For the warm-up today, what I want you to do is take out your notes from 1.6. Take those out, and then we're just going to end up finishing one of these examples because I don't think we finished it, and this is a good chance to review absolute value function. So you can go ahead and pause the video if you need to, but I want you to attempt example 6 in lesson 1.6, which is an absolute value function. All right, so how do we graph this absolute value function? Well, what we've been doing for so long in this section is if we don't know any shortcut or easy way, we can always make a table of values. So I'm simply going to make a table of solutions here with x and then f of x, my result. And I'm going to plug in different values in for x into my domain. Now, I told you yesterday that it is helpful to know that what's inside this absolute value function. Okay, I'm going to put it over here. How do we find this vertex? How do we find the critical point of the absolute value function? And we can find that out by looking inside the absolute value, which in this case is x plus 1, and just asking ourselves, when does that equal 0? For which x value does x plus 1, or inside the absolute value, equals 0? So if we solve that, you can see that x equals -1, right? This is going to be a critical point here. Now, you can know that going into it. You can also just pick a bunch of values and eventually figure out that x equals -1 is that vertex point. But what I would do is the first point that I plug in here is going to be -1 for x, because I know that's going to be my vertex. It's going to be my point. So I go ahead and evaluate this. All right, so I plug in -1 into my function. So -1 plus 1, so -2 times the absolute value, -2 times the absolute value of 0, which is 0. This comes out to 0. So this is my first point. If I plug in -1, I get 0. So right here, I know that this green point is going to be the vertex. So after that, let's just pick some points that are to the left or to the right of -1. So I'm going to go ahead and plug in something else like -2. What happens if I plug in -2? Well, now I have -2, and I'll plug in -2 there, plus 1. And so I say this is -2 times the absolute value of -1, because -2 plus 1 is -1. Well, this is going to be -2 times the absolute value of that is +1. So it's -2 times 1, which is -2. So all in all, if I plug in -2, my output is -2. And so -2, comma, -2 is another point on my graph. So that's down here. Okay, so I know this is the vertex, the point up there. I'm going to put this in a different color here. I know this is the vertex right here. Since I know that's the vertex, I know that these points are going to continue this way right here. Okay, because I only need one other point to figure out that this line is going to continue in this direction. So I could plug in, -3 if I wanted to. You don't need to. But if you plugged in -3, what do you get? You would get -2 times the absolute value of -2, which is -2 times 2, which is -4, right? If we did that, you would get -4, and the point that we would get is -3, comma, -4. Well, we already know it's going to be -4 because I just drew the line. -3 does go to -4, and we have it. Okay. Now we can also plug in values to the right or the other side of the vertex. So what happens if we were to plug in our next x value, which is 0? Plug in 0 there. We would get -2 times the absolute value of 0 plus 1, which is -2 times the absolute value of 1, which is also -2 as an output. Remember, the absolute value function is just taking whatever value is inside of it and making it positive. So now we have the point 0, -2, and that's going to be right here. And again, I know that's the vertex, so since I know that's the vertex, I can really utilize that. I don't really need to plug in any more points. I can say that this is going to be connected to this, because it has to be. Okay. If I kept plugging more and more and more points in, of course, those points are just going to keep following along on the line that I just drew, right? So that is how we graph the absolute value function. If we're going to talk about the domain and the range here, domain is going to be all real numbers. Right, you can plug in any x value and you can see that the graph is going left and right. So -infinity to +infinity is the domain. Or you could write, I never write this anymore, but the set builder notation is what the book will use often. All x values such that x is an element of the real numbers. Okay, that's another way to write the same thing. And if we talked about the range, what should you have gotten for the range? Well, that would be all the y values or all the f of x values that are less than or equal to 0. So we would say from -infinity all the way to 0 for the range. Set builder notation for that would be a little bit more specific. It would say all the f of x values such that f of x is less than or equal to 0. That would be our domain and range for that absolute value function.